All right, I found my issue, so I'm just going to jump back in. I said that 180 minus 20 minus 30 was 150. It's 130 because I can do math. So if I go back and change my cosine in here to 130, then I have 1,000 squared plus 1,200 squared minus 2 times 1,000 times 1,200 cosine of 130. If I square root that answer, that will be the distance between them. 1,995.6679 miles. That looks a little bit better. All right, last one. The four sequential sides of a quadrilateral have lengths 4.5 centimeters, 7.9 centimeters, 9.4 centimeters, and 12.9 centimeters. The angle between the two smallest sides is 117 degrees. What is the area of this quadrilateral? So I'm going to try to draw this thing. It's not going to be to scale, so don't judge me. So we have a side, a side, a side, and a side. So it said in order, the side lengths are 4.5 centimeters, 7.9 centimeters, 9.4 centimeters, and 12.9 centimeters. They also said the angle between the two smallest sides is 117 degrees. We want to find the area of this quadrilateral. Now, once upon a time, I'm actually going to show you my notes for once. Once upon a time when I solved this, I broke it into two triangles, and we know that the area of a triangle is 1/2 base times height. So I had to find the base and the height of both of these triangles, and it took quite a lot of work. So then my fabulous pre-calculus students said, we found this other formula, can we use it? That formula is called Heron's formula. What it allows you to do is find the area of a triangle without having to know the base and the height. So I can still break this into two triangles. And I'm going to try using this Heron's formula. What Heron's formula says is the area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to the sum of the three sides all divided by 2. I don't know how they came up with this, but hey, I'm happy to use it if it makes our life a little bit easier. Because I know two side lengths of each of the triangles, if I can find this diagonal length in green, that's going to allow me to find my third side. So let's see if we can do that. If I look at this upper triangle, I have side, angle, side. So I can use the law of cosines to find that green length. I'll just call it D for diagonal. That diagonal squared is equal to 4.5 squared plus 7.9 squared minus 2 times 4.5 times 7.9 times the cosine of that 117 degrees. 4.5 squared plus 7.9 squared minus 2 times 4.5 times 7.9 cosine of 117. Square root that answer to give me my diagonal to be equal to 10.7209. So now that I have that length, 10.7209, I'm going to use this Heron's formula. So I'm going to start with, I want more colors. I'm going to call this triangle 1. We'll find the area of that one first. The S value for triangle 1, I'll call it S1, is equal to, add up the 3 side lengths and divide by 2. So that's 4.5 plus 7.9 plus 10.7209, all divided by 2. 4.5 plus 7.9 plus 10.7209 divided by 2 equals 11.56045. I'm going to save myself some problems later. I'm going to store this in my calculator as x. So I'm going to press my STO arrow button, x, and hit enter. And you'll see why in just a second. Now I can find the area of this triangle. So the area of triangle 1 is equal to the square root of S, I'm using S1 because it's triangle 1, times S1 minus the first side length, 4.5, times S1 minus the second side length, 7.9, times S1 minus the third side length, 10.7209. Now I don't have to type 11.56045 each time because that's x to my calculator. So I want to take the square root of x times x minus 4.5 times x minus 7.9 times x minus 10.7209. That should give me the area of my first triangle. The area of triangle 1 is 15.83777. Now we're going to do the same thing for the second triangle. The S value of my second triangle, I add up the 3 side lengths, 10.7209 plus 9.4 plus 12.9, all divided by 2. I get that my S value for the second triangle is 16.51045. Like I did last time, I'm going to store this as x so that I don't have to type it out 1,000 times. So the area of my second triangle is equal to the square root of S2 times S2 minus 10.7209 times S2 minus 9.4 times S2 minus 12.9. Let's see what we get. The square root of, I called it x, times x minus 10.7209 times x minus 9.4 times x minus 12.9. I get that the area of my second triangle is 49.5372. And hopefully it makes sense that it's bigger because the side lengths are bigger than the other triangle. So it being bigger, hopefully that makes a little bit of sense. So the area of my whole quadrilateral is the sum of these two. So the total area, that's supposed to be a T, total area is equal to 15.83777 plus 49.5372. Gives me a total area of 65.37497. We were working with centimeters, but this is area, so it will be in centimeters squared because area is a two-dimensional measure. This is still a lot of work, but nowhere near as much work as it would have been the other way. So thank you, Heron, for your formula. We appreciate it.